Hello, welcome to the Geotechnical Engineering Part 1, Soil Structure. Today we'll be discussing about shape of particle, texture and structure of soil. What is soil structure? The arrangement of primary particles such as sand, silt and clay and their aggregates into a certain definite pattern. So this definite pattern is said to be the soil structure. Now what are the influence of soil structure on soil physical properties? There are aeration, temperature, density, consistency, color, etc. Now let us discuss shape of soil structure. First one is patty. Top flattened layer of 10 mm thickness, mainly found in the A origin of forest soil and laky sediments. Next one is prismatic and columnar. Prism like pads are long in vertical dimension. Here you can see 10 mm wide to the 100 mm wide. Prismatic pads have top flattened, columnar head have a round top, tend to form in B origin. In high soil contains sodium where clay has accumulated. The third one is angular and subangular. Blocky pads are imperfect cubes 50 mm, angular having sharp edge and subangular having round edge. Formed in B origin where clay have accumulated and indicate poor water penetration. Granular and crumb. Spheroid bed of polyhedron up to 10 mm, often found in the A origin in the presence of organic matter. Crumb pads are more porous and are ideal considered. Now, what are the factors of soil structure? Climate is one of the factors influencing the degree of aggregation as well as on the type of soil structure. In arid region, you can see the little aggregation occurs. In semi-arid region, degree of aggregation is greater. Organic matter, which improves the structure of sandy soil and clay soil. In sandy soil, sticky and slimy material produced by decomposition on cement, the sand particles together to form a aggregates. In clay soil, it modifies the properties of clay by reducing its cohesiveness and this clay form crumbly. Absorbed cation mainly due to the sodium and calcium content. Sodium has deflocculation forming the pore structure and calcium has flocculating structure which is good as structure. Tillage, intensive cultivation increase the infiltration capacity and penetrability but spoil soil structure. So often good soil structure tillage operations should be made at OMC, optimum moisture content, or you can say optimum moisture condition. Type of vegetation, grassland and forest soil have high stability of aggregation. Animals such as earthworms and moles and insects that burrow into the soil are the chief agent that take place in the aggregation of finer particles. Microbes like algae, fungi, antinomystic. These are kept the soil particle together. Fertilizer like sodium nitrate destroy the granular by reducing the stability of aggregates. Now wetting and drying process also. In drying, soil is wetted. The soil colloids swells on absorbing water. On drying, shrinkage produce strain in the soil mass give rise to crack, which break it up in the cold and granular of various size. Soil textures, which refers to the percentage of sand, silt and clay in the soil. The proportion of each size in the given soil cannot be easily altered and it is considered as the basic properties of soil. These soil separates are defined in terms of diameter in mm of a particle, millimeters, which we are analyzing by sieve analysis. Particle size less than 2 mm, finer earth are excluded from the soil texture determination. It includes sand, silt and clay. So sand has about at least 70% of the material by weight, silt 80% and 12% clay, and clay consists of 35 to 40% in the soil. This triangulation classification system was suggested by US Bureau of Public Road. This is called texture classification. In this triangle, sand, silt, clay percentage is being noted, where this triangle is divided into 10 zones. So using the percentage of clay, sand and silt, we get exact classification of soil. Here you can see the sand, silt, clay properties influencing the soil structure, or you can say soil texture. Water absorption capacity is low in sand, medium in silt and high in clay. Aeration process is good in sand, medium in silt and poor in clay. Drainage rate high in sand, medium in silt and very slow in clay. So likewise you can see different properties influencing the soil structure. Structure of soil is mainly classified into the 6 categories. We'll be discussing one by one. Single grained structure, also known as coarse grained soil. Soil particles deposit due to the gravity, where you can see the loose to dense state is 0.35 to 0.90 voids. Here coarse grain particles are denoted as single grain structure. Honeycomb structure formed by cohesive soil, which is, you can say it as a fine sand. Particle size 0.002 to 0.02 mm. Deposited, they form particle to particle contact and bridge over large voids. Here you can see the large voids in the soil mass. Flocculated structure formed by clay particles. Interparticle contact between the positive and negative charge surface. Disperse, you can see, formed by remolding, edge to edge orientation or face to face orientation. This is a dispersed structure. mixed soil structure, which may be quartz grain and clay matrix. Here you can see the quartz grain figure and clay matrix, where clay particles are more and quartz particles are less. Thank you very much for listening. Thank you.